This video, we're going to use the quadratic formula to solve quadratic equations. So just a refresher for what the quadratic formula is. If we have a quadratic equation written in the form of ax squared plus bx plus c equals 0, we've got to start off with it that way. Usually we want a to be a positive leading coefficient, though it doesn't have to be. Then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Most important thing to tell you is if b squared minus 4ac is less than 0, meaning it's a negative number inside the square root sign, we'll choose the option that says the solution is not a real number. Otherwise, we're going to have real solutions. We may have one or two real solutions, and those solutions may be rational or irrational. And we'll get to that as we go along here. I've written the problems out for you already. There's lots of problems. These problems from 8.2, we changed the directions. That's what the little star means. But the main section that the problems are going to come from is 16.3. So let's go ahead and get started here. We have an example here of 7k squared plus 9k plus 1 is equal to 0. A is equal to 7, B is equal to 9, and K is equal to 1. C is equal to 1. So we need K equal to negative 9 plus or minus the square root of 9 squared minus 4 times 7 times 1 all over 2 times 7. K is equal to negative 9 plus or minus the square root of 81 minus 28 over 14. 81 minus 28 is 53, which is not a perfect square, nor does it contain a perfect square as a factor. It's a prime number, I believe. So we're just going to leave that as it is and write our answers as negative 9 minus root 53 over 14, comma, negative 9 plus root 53 over 14. This is one of the techniques that we like to use when factoring isn't extremely obvious to us. That problem was like number 3. We've got 3 minus x squared equals 4x. So I want to take everything over to the side that makes the term with the x squared positive. Just makes my life easier. A is 1, B is 4, C is a negative 3. X is going to be a negative 4 plus or minus the square root. 4 squared is 16 minus 4 times 1 times 3 is 12. Over 2 times 1 is 2. Is negative 4 plus or minus root 4 over 2. Because this is a perfect square, I could have factored this. Sorry, minus 4ac, that's plus. This was not factorable. So it's 28. But there is a perfect square of 4 in there, so that's 2 root 7 over 2. That looks better. So this is going to be a -2 plus or minus √7 when I divide everything by 2. And so my answers are -2 minus √7 and -2 plus √7. Watch out for your signs when you multiply a negative times a negative. I almost made a sign error there. But if this square root had been had gone away because what was inside was a perfect square, that would have told me that I could have factored the original problem, but I knew I couldn't factor the original problem. So I looked for a sign error there. That was like number 15. Let's do one like number 21 now. Y squared minus 10y plus 20 is equal to 0. So A is 1, B is -10, and C is 20. Y equals -10 plus or minus the square root of -10 squared minus 4 times 1 times 20 all over 2 times 1. Y equals 10 plus or minus the square root of 100 minus 80 over 2. 100 plus or minus √20 over 2 is 100 plus or minus 2√5 over 2 is 50 plus or minus √5. Okay, so y equals 50 minus √5 and 50 plus √5. So far we've gotten everything has 2 irrational answers to it because we've had square roots that are left. We might get something different here in just a little bit. So let's keep going and see if we get any of those situations that have only one answer or have 0 real answers. Let's look at one that's like number 37 here. M squared over 4 equals m plus 1/4. I don't like the fractions very much, and there's no reason for me to keep them because it doesn't change the answer if I have fractions or don't have fractions. It just makes my problem a little messier. So I like A, B, and C to be integers if I can, as long as the integer that I'm going to square doesn't get too big. Let's leave it with fractions though for right now, just so we practice with them, but it won't change the answer if, let's write everything on this side before I get started. So I don't just change signs on you and not explain. Okay. So this is m equals a -1 plus or minus the square root of a -1 squared minus 4 times 1/4 times a -1/4 all over 2 times 1/4. M is going to be a +1 plus or minus the square root of 1, and then a -1/4 times a -4 is 1. So this is going to be plus 1/4. 2 times 1/4 is going to be 1/2. This is going to be 1 plus or minus √5 over 4 over 1/2. M equals 1 plus or minus √5 over √4 is 2. And then this is going to be divided by 1/2 is the same thing as times 2. So this is 2 plus or minus √5. So m equals 2 minus √5, 2 plus √5. There's two answers to that. It would have worked out exactly the same, and I'll go back and do it right now. See that we get the same answers. If I had multiplied through by 4 to clear my fractions, and have gotten m squared equals 4m plus 1, m squared minus 4m minus 1 equals 0. Let's change these numbers over here. 1, -4, -1, and m would be equal to negative b plus or minus root b squared minus 4ac all over 2a. It's going to be 4 plus or minus root 20 over 2, 4 plus or minus 2 root 5 over 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Remember, we've got to divide both parts by the denominator, and that should be the same thing that we just got a minute ago. Sometimes it's easier to deal with the fractions, especially when we have that 4 times on the inside, and we keep the numbers a little bit smaller that we're squaring. Other times it's easier to get rid of those fractions so we don't have to divide by a fraction in the end. You'll get better at choosing what you want to do. Now let's look at one that's like 16.3, number 46. 2x squared minus x equals to 5 halves. So again, we can just keep that 5 halves. That's not going into the denominator, but the divided by 2 will eliminate with the 4. Let's keep our numbers small here. 2x squared minus x minus 5 halves is equal to 0. So our a is equal to 2, b is equal to -1, c is equal to -5 halves. Our x is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. 2 goes into 2 one time. -4 times -5 is 20. 20 plus 1 is 21, like so. And root 21 doesn't break down anymore. So this is 1 minus root 21 over 4 and 1 plus root 21 over 4. All right. Let's go ahead and look at a couple more problems here. I'm going to come back and look at one like number 1 now. Here, x squared plus 7x plus 8 equals 0. So a is 1, b is 7, and c is 8. X is going to be negative b plus or minus the square root of b squared minus 4ac is 28. All over 2a is 2. It's -7 plus or minus root 21 over 2. And so this is -7 minus root 21 over 2, and -7 plus root 21 over 2. So far, everything's been pretty consistent on the type of problem that it is. Let's look at one that's like number 13 now. M squared minus 12 equals 4m. So we're going to have to subtract 4m from both sides to get everything on the same side to get started. Get that set equal to 0. A is 1, B is a -4, and C is a -12. So we have m is equal to 4 plus or minus root 4 squared is 16. 4 times 1 times -12. Watch, those two negatives are going to make a positive, over 2a plus or minus root 16 plus 48 over 2. 4 plus or minus root 64 over 2. Okay, so this is one of those ones where this is a perfect square. So this should have been factorable. It's going to be 2 plus or minus 4. 2 minus 4 is going to be a -2. 2 plus 4 should be 6, which means that this should have broken down into m plus 2 times m minus 6. And we should have been able to solve it from there. So 2 times -6 would have given us -12, and 2 minus 6 would have given us -4. So see how if this is a perfect square, in here we get two rational answers, and that means that it could have been solved by factoring, though our instructions told us to solve this by using the quadratic formula. All right, let's clear this out. And let's look at this next one. X squared plus 4x plus 13 equals 0. So our A is 1, our B is 4, and our C is 13. So x equals -b plus or minus the square root of b squared minus 4ac. Uh-oh, that's going to give us a negative number all over 2a. I'm going to keep going and I'm going to solve this out because we already know about complex numbers, but and the instructions here were changed to tell us type an exact answer using radicals and I as needed. So they want us to go get those complex numbers since we've already talked about complex solutions. So that's what these two problems are going to be about, is that they're the case where we get complex answers. So let me just find the difference between 52 and 16 here is 36, but it's going to be a -36. So that's going to be a -4 plus or minus 6i. And I'm going to put each of these over 2 is going to be a -2 plus or minus 3i. 6 divided by 2 is 3. So x equals -2 minus 3i. I'm a -2 plus 3i. So we're getting two answers to the problem. They're complex solutions, complex answers, because they have a real part and an imaginary part. And this imaginary part comes because we have a negative left in our discriminant inside of the square root sign. Right? Let's look at one more problem that I believe is similar to that last one. Okay. Two more problems, excuse me. So I've got 2x squared plus 5x plus 8 equals 0. So this one is like 31, then I'll go back and do another one like 23 to finish up here. So we have our A is 2, our B is 5, and our C is 8. Our X is going to be negative B plus or minus the square root of B squared. That's 4AC. So 4 times 2 is 8. 8 times 8 is 64. 64 minus 25 is 39. 2A is 4. And all that I can do here is pull that I out. And write this as negative 5 over 4 plus root 39I. Make sure you're clear that the I is on the outside, and negative 5 over 4 plus root 39I. And notice that I want to write those in standard form with A plus BI and A minus BI. I don't write it all over the common denominator. Oops. I say that, meaning that I want to put them both over their individual denominators, which I almost forgot to do. But I don't want to write it all over a common denominator. That's not standard form for complex numbers. So I should have negative 5 over 4 plus root 39 over 4 times I, comma, negative 5 over 4 plus root 39 over 4 times I. Right? And last one for this video will be x squared plus 6x plus 18 equals 0. So our A will be 1, our B will be 6, and our C will be 18. X is going to be negative B plus or minus the square root of B squared minus 4 times A times C. 4 times 18, 32, 72. Okay. 2 times 1 is 2. It's negative 6 plus or minus root negative 36 over 2 is negative 6 plus or minus 6I over 2 is a negative 3 plus or minus 3I. So x is a negative 3 minus 3I, or a negative 3 plus 3I. That's it for this video. We'll come back next time and talk some more about using the discriminant to determine the number and type of solutions to the quadratic equation. So I made a little bit of reference to that in this video, but didn't go too deep into that because that's actually the topic of our next video. So see you back here for our next video.